Hello everyone. So I just opened my Facebook and I got spammed with tons of different ads of this Gemini AI, which is the AI from Google, I guess. And obviously this is a fake ad because as you can see here, there's a URL here, and this URL is not an official URL. And well, I got tons of these ads here. I got a couple open here, and they actually got a lot of likes, different likes and comments. For some reason, I cannot see the comments, even if I sort by relevant or by newest. I cannot see any comment in any of these ads. I cannot see the comments, but I can see the shares, the people who shared it, and there are a lot of people sharing it. In this one here, we got 500. This one here is a bit new, so not too many people, but a lot of likes, and all of them are pretty much the same. They have this link pointing to some subdomain of lpages.co, so all of them are the same. And if we enter in this link here, let me see if this still works. Yeah, it's some gibberish thing about Google Gemini AI, and there's a download button which points to a Google Drive. This is the direct link of a Google Drive hosted file, and here it gives us the password to unzip the file. So in this one here, the password is this number. Let me see this one here. Yeah, in this one the password is quad8, and in this one I guess it will be different as well, but pretty much all the files are pretty much the same. And I already downloaded. I have this here in my Kali Linux VPS, and let's make some analysis. Let's see what's going on here. So I'm gonna unrar this file here. The password for this one is 8888, so quad 8, and it is a setup.msi file. This is a Windows file, which if we open, it will open the wizard for us to install something. It will just ask us for a path to install, and then next install, and it will decompress a bunch of things in some specific path. And we can actually see what's going on inside this file using MSI extract. I don't think this is a native Kali Linux file, but you can simply just apt-get install this here. We need to specify the file that we want to extract, which is the setup.msi, and automatically it shows us what's going on inside this file. So we have here the install.cmd, which is the file that will be run when we open this setup and install it. There's a logo.iclo, some DLLs, which as far as I know, they are not used by, we are analyzing this, but for sure this is a malware, and I already analyzed it before. And these DLLs here, they are not related to the malware. I guess this is something related to the MSI file itself. But we have this install.cmd, we can take a look at it. And this is just a Windows CMD file. We can see here it is invoking PowerShell, it is bypassing any execution policy, and it is running a file, a PS1 file, that is a PowerShell file, which is located in this folder here. This %DPO, this is, in Windows, this is pretty much just as the pwd command in Linux, so we will get the current path. And anyway, this install.cmd will run this url.ps1 file, and we can take a look at it as well. And this is the code that will be run. So it first starts killing these three browsers, so Chrome, Edge, and Brave. If you are, for example, here I'm running Brave. If I run this setup.msi, at the end it would kill my browser. It would test if this path here exists, and if it doesn't exist, it will change the value of this variable et here to the same as before, but without the x86. So it will check if I have this path here, and if I don't have it, it will save in this variable this other path, which is similar to this one before. There is this URL to open variable, which holds a link to a Google page related to this Gemini AI, and it got a couple arguments in this array here. And after this, it verifies if Chrome is installed, and it does this by checking this registry entry here. If it does exist, that is, if it is not equal to null, it will start the Chrome itself, and it will pass these arguments here. So it will load an extension, which is the one saved in this ET variable that we just saw here, and it will create a new window opening this URL to open, which is the link to Google's Gemini's AI. And it will do pretty much the same for Edge and for Brave as well. So this code here, it is just killing all the instances of these browsers here that you may have open, and it will reopen them again, but now loading this extension here. As we can see, this follows a weird pattern that I'm not pretty sure how it is, but by experience I can tell this is the ID of a browser extension. And if we look closely, we can see that this starts with nmmhkk. This is exactly the name of the folder in which this file is. So if we ls this folder nmm, we can see some other files here. We can see the ru.ps1 that we just saw, and there are another files here. So these are the basic files for a browser extension. We can see here the background.js, which is the worker, another JS file, we have a fave icon, and a manifest.json. We can take a look at this JSON here. And here it tells us a couple info about this extension. So we can see here the name of this extension is Google Translate, and the description is also about the Google Translate, which doesn't make sense at all because this was supposed to be something related to Google AI and not Google Translate. But I guess this is something they did just to make this malware stealthier, because people would just see the Google Translate icon and they will think that this is something normal. Which actually, this fave icon, I cannot open it because it isn't a VPS here, but I already took a look before, and this is just the Google Translate icon, normal. And okay, we can see here that the background.js is the worker. This is the actual code that will be run by this extension. And down here we have something really important, which is in which websites this extension will work. And we can see here that this works on Facebook. Any subdomain on Facebook, any schema, HTTP, HTTPS, any other possible schema, and anything after the bar. So this will work on anything related to Facebook, and it will run a script contained in content.js. Here we have the definitions of the icons and nothing more beside this. We can take a look at this content.js, which is a smaller file. This background.js has 17 kilobytes. This one here is just 250 something bytes. We can take a look at it. Yeah, let me put the name of the folder here. And this is the content.js. So it is checking if this content script executed exists, if this is an item that exists in the local storage. If it is not, then it will pass a message to this worker, to this background worker, which is the background.js. It will tell this to run. And then after it run, it will create this content script executed and will set it to true, which was false before because it didn't exist. So this here is a mechanism to make sure that the actual code, the actual piece of code of the malware will be run only once, because on the first time it runs, this here will be false. It will enter this if and it will run the code. And then it will set this content script executed to true. So in the second time that this extension will be loaded, the content script executed will be true, so the if would not pass. It wouldn't enter in this if here, so it wouldn't run the code again. And we will see that this is important because, as we will see, this malware sends information about the victim to the attacker, and you as an attacker wouldn't want to have the same information came across your C2 over and over again. So this is a way to make sure that your code is run only once. Okay. And we can take a look at the main file, which is this background.js. The problem is it is obfuscated. We cannot read this. We can see there's a bunch of hexadecimal codes here. There's an array. This is actually pretty common in some obfuscations, in some JavaScript obfuscations. So you just get all the strings of the files, you encode in it, either in base64 or in hex or in anything that you can decode easily after. You put all the strings on an array, and then you refer to each string as the index of the array, as we can see here. But the names of the variables, like this one here, damn, no limit, nav equals to navigator user agent. The names are preserved. So the guy who did this, he just scrambled everything. He didn't change the name of the variables. So there's a bunch of ways we can decode this, and I found this online Deobfuscator here, which is pretty cool, and it has a feature that I've never seen before. So if we put the code here, it will automatically try to decode it and beautify it, and we can see here, so the array that I told you with all the strings used by this code. But well, we can read it. It is not in hexadecimal anymore. We can get an idea of what these guys do by looking into these strings here. But if we scroll down, it would still be a pain in the ass to know, for instance, what will be the accept language. So we'll have to look in this array, get the 7th index, and then replace it here, which is not cool. But this decoder here has this auto decode function here, which already does that automatically to us. So all those strings are already placed in where they should be. And now we can take a look at this code. So this is not a big code. There's this big index, big array here. But the code itself is not big, and it's actually pretty redundant, as we will see. So let's take a look at it. So first it defines some variables. There's this array here which has some exchange rates for some currencies. So the first one is dollar, and we have a lot of different exchanges, and their value is related to dollar. So $1 equals to one, I don't know, BSD, which I guess this is the Binance dollar, but $1 equals to 0.19 Brazilian reais, for instance. After that, we have the definition of some headers. So here we can see the values of the headers that we couldn't see before, and this here will be used after, because this extension does some requests to the Facebook API, and it uses these headers here to mimic a real browser. Here we have this function which returns the cookies that a user have on Facebook, facebook.com. So it returns the cookies on this variable cool here. And we have a function getToken. So this function getToken will receive the user cookie, and it will make a request to this endpoint here. If you open this web page on a logged in Facebook account, and if you see the source code of this page here, you can hit Ctrl F and search for access token, and you will see that the token of your account is hard-coded on the page itself. So this here is just making a request to this page. It will search for access token, and it will use some regular expressions to extract the code, the access token itself, and that's what this function do. And it is funny because it tries to do this, and if it gets an error, it will try to do the exact same code again. That's why I say the code is very redundant. This here is not needed. Actually, I don't think it makes sense to run the exact same code again in a catch after you try to run it and it gives an error. But anyways, this function here just get the token of your account. There's this function here to convert some amount of money into dollar. So you put the currency, for instance Brazilian reais or euro or something, some currency, and you put the amount, and it will convert it to dollar. The funny part is that it checks if the currency that you put is dollar. If it is, then it will just return the amount itself, because $1 equals to $1 for any amount of dollars. And if you put a currency that is not listed on this list here that we just saw, for some reason it returns 100,000. I don't know what's going on here, but yeah, otherwise we just multiply the amount for each one of these values here, depending on the currency that you choose. So this is a function to convert an amount of currency to dollar. And then after that we start to see some more interesting things here. So it checks if the cookie of the user contains this string here, and if not, so if it doesn't contain, the code will just stop. It will return, and this function will stop. And after that it will get the token of the user, and then it will fetch, it will make a request to this endpoint here. This is an old endpoint. This is the version 8 of the Facebook API. It is in version 12, I guess, so there are other requests here that use, actually 14. It uses another version of the Facebook API. I'm not sure why it does this, but if we open this link here, pass in our token, the token that it got doing this request here. If we open this, it will return a JSON containing information about the pages that we can manage. So if you have a page, it will show a JSON, a list of your pages, and information about if the page is verified or not, if you're an admin, what permissions do you have and stuff. And this is what the code is doing here. So it is checking if the item data isn't empty, which means that you have some page, and it starts to make some verification here. So it verifies if your page is a business. If it is, it will save that information. If you have permission to manage, or in a word, if you're admin of the page, it will also save this. It will save your page is verified or not, and the amount of likes that you have. And if you have more than 10,000 likes on your page and you are admin of it, it will also save that information here. And at the end, it pushes everything in this my list. After that, it would do something very, very similar, but in this other endpoint here, which is not related to pages but to business. So if you have a business profile, it would check if it is verified, if it is eligible, which I'm not sure what does it mean. Is something specific related to Facebook, but I think it is some kind of limit, because it checks if your account is eligible, and if it is, it will set the value of this check 350 to 350. Otherwise, it will change the value of it to 50. So I guess this is a limit, maybe like a threshold, a limit of money that you can put, or a limit of ads that you can run. I'm not sure. It checks the verification status to see if your business account is pending or reject or something. And if it is good, it will save that information as well. Finally, it gets the date of creation of your account. It joins everything into a string and it pushes it again in this my list here. And we have the third block of code, which is similar to this one before, but the endpoint is now for add accounts. So the first one gets information about the page that you can manage. The second one verifies if you have a business profile, and this third one here verifies if you have an ad account, and it gets these fields here, right? So it checks if you have an ad account, and if you do, it checks for this account status here, which is a number. It is an integer number, and if the status is 2, it will update this STT variable, which I guess stands for status. It will update it to die. If the status is 3, it will update it to no. If it's 9, it is unhum, and if it's 101, it is close. But I've searched about this account status here, and I could find a reference which was offline, but I could recover it here in Wayback Machine. And we can see here, this is the official Facebook documentation for this API, and we can see that the account status it holds some numbers, and this here verifies for 2, 3, 9, and 101. So disabled, unsettled, in grace period, and temporarily unavailable. So this here just it starts with the status live, and it checks if the actual status is something bad. So if it is disabled, unsettled, unavailable, etc. If it is not, it will not enter in these ifs, and it will hold the value live. Okay, so this here is just to verify the status of your account. It then checks for these currencies here. So when you have an ad account, you put money on it to run your ads, and you need to make a deposit on some currency, so dollar, euro, something, and it checks here if the currency that you use is not one of these here. So we have these from Indonesia, this is from Hungary, Vietnam, Colombia, this is for, I think this is Costa Rica, and this is Iceland. So I'm not sure why it does this, but for some reason it checks if the currency is not one of these, and if it is not, it will save the threshold amount in this variable, but before that it will divide it by 100. I actually also don't know why it does this. It actually does the same here. It saves the amount spent. If you already spent some amount of money in your account with ads, it will divide this number by 100, and it will save here, and also here the balance. If you have any money in your balance in your account, it will also divide by 100 and save it here. Not sure why it does this. It checks if your account is prepaid, which I think is the kind of account that you put money on it, and then you can use the money to run the ads instead of running the ads, and then after you pay for how many people saw the ads or something. Then it checks if you use this another currency here, which is the Indian rupee. It then converts the limit that you have in your account, the amount of money that you have available to make ads, it converts it to dollar, and it makes some checks here. So if your limit is between 35 and 240, it will save that information in this variable here. If it is zero, actually if it is higher than 240, it will save this value. If it is higher than zero, it will save this value, and if it is equal or less than zero, it would save this value here, this no limit variable. So this is just checking how much limit do you have available in your account. After that, you get the creation time of your account as well. Joins everything together in this adds string here, which will contain your ID, the status of your account, the currency that you use, if your account is prepaid. This here is the limit, I guess. Actually, I'm not sure. I think this is limit in Vietnamese, but we have limit here, which holds this at trust. So I'm not sure what does it means. We have the limit converted in dollar, the amount spent, and other information here. Then here we have another chain of ifs. So it will check if the status is either live, no, close, or this unhum. And if we take a look closer here, this is just verifying if the status is not die, because die is the only one that is not on that list. So we have live, no, unhum, and close, which is what's being verified here. So this is just checking if your account is not die. And if it is not, it then checks if the limit is higher than 180 or if it is negative, which I also don't know what's going on. And if the JSON has this property here, adds payment cycle. If so, and if the amount that you spent is positive, if you already spent something on ads on your account, it will save that information here. It will save this on this add variable, which it then checks right after this. It checks to see if you spent some money. If so, it would save your account as a VIP. Not sure why, but maybe the attacker wants to know that, oh, okay, so this guy already spent some money, maybe his account is already verified, he has some credibility on it or something. I don't know. And then here we have another bunch of ifs, which is pretty much the same thing as we saw before here. This is just checking the limits of your account. Remember, we saw this dem 50, dem 250. This variable is set where it is set. Let me see here. Let me copy and search. So it is set here on the limit. So if your limit is higher than 240, it would set this variable to positive, and that's what's going on here. So this is just duplicate code, doesn't need to do that. Anyways, after that, it then gets your IP address. Remember that all of this code here is run inside the extension that is installed. So this is running on the victim's machine. This will get the victim's IP address, as well as the country, the city, the zip code, and the ISP of the victim. And then it would create this variable tongue here, which contains this variable cool, which is the cookies of the user, the Facebook cookies for this user. We have this string nav, which was defined up here, which is the navigator user agent, the IP address, and the information about the account, the limits, etc. So it creates this string. It verifies if the string length is higher than 4,000 bytes. For 1,000 bytes, if it is, it truncates it, encode it in base64, encode it in URL, and then at the end it sends everything that we just saw here. It sends everything to this managedkeyv.com. It sends it via get to this URL here, and there are other catches here which do pretty much the same. It actually says if you have an error, depending on the error that you got. This is just for the attacker to debug what's going on. So this is pretty much it. I haven't taken a look at this. Let me do a curl here. Yeah, so there's something running on this website. So we have PHP, okay, WPJSON. So there's a WordPress running here. Yeah, just trash. We could do like we could fuzz this URL to see if there's something interesting here, but I don't think it's worth now. Oops, robots. Let me just take a look at the robots. Okay, yeah. So this malware here, once installed, it will reload the browsers that you have and load an extension. This doesn't work with Firefox, just with Chrome-based browsers. So it would load an extension, and this extension is meant to run on Facebook URLs. It would list the page that you have permission to access and save a log if it is a business page, if you are admin of the page, if the page is verified or not, the number of likes that you got. If it's more than 10,000, it would say that it would save that with a different warning. It would check your business, if you have a business account, a business profile, if it is verified or not, if it is eligible for monetization with ads, would save everything. And at the end, it would check if you have an ad account. It would see the status of your account, if it is somehow restricted. It would see the currencies that you use to make a deposit of money on it. Not sure why it does that. Make some calculus to get the threshold, the amount spent, the balance that you have, if it is a prepaid account, the currency that you used. It would save the amount of limit that you have on your account. And then after that, it would just wrap it up and send it to this URL here, which is the attacker's C2 command control. Okay, so this is the first stage of this malware. We cannot be sure of what this is actually doing because this is just sending information about your account to the attacker. But I think the attacker used that information to feed back, to spread the malware more and more, because as we can see, oh, it just disappeared. Yeah, okay, so it's now all disappearing, but all of those ads had tons of people sharing it, dropping comments, and I guess those people got hacked, and the attacker has like a script in which he just put all the tokens that he harvested with this, and the script just goes there and like and share everything. But we cannot be sure about the final purpose of this. Maybe the guy is just getting all of these tokens and infos to sell on the black market. I don't know. But that's it. If you know anything about this, if you have any other information, please drop a comment below, and I'll see you in the next video.